Good evening, class. Here's practice test number 2, module 2, covering chapters 3 and 4. Chapter 3, functions. Chapter 4, linear functions. Again, I want to remind you of the pledge, and the emphasis is that when you take the exam, you take the exam on your own without any help. So I pledge on my honor that I will neither give nor receive unauthorized assistance, so on and so forth. All right, so here's the first part, chapter 3, functions. So let's start with some definitions. Dependent and independent variable. For an equation in variables x and y, if the value of y depends on the value of x, then y is the dependent variable and x is the independent variable. So we want to discuss the concept of a domain and range. Relation, a set of ordered pairs. Domain, the set of all input values, x values, the independent variable for a relation. Range, the set of all output values, y values, dependent variable for a relation. In other words, if we are looking at a graph, if we lay it down along the x-axis, what it covers is the domain. If we lay it down along the y-axis, what it covers is the range. So here, that would be the domain. It continues indefinitely on both sides, makes it all real numbers. Range, it covers indefinitely on both sides, up and down, all real numbers along the y-axis. Function. A function is a relation in which each element in the domain corresponds to exactly one element in range. In other words, the x can't repeat. So it has to pass a vertical line test, meaning what is a VLT or vertical line test? If a vertical line can be drawn so that it intersects a graph at more than one point, then the graph doesn't represent the function. If a vertical line cannot be drawn so that it intersects a graph at more than one point, then the graph represents a function. A function is one-to-one if each element in the range corresponds to exactly one element in the domain. In short, in the case of a function, x can't repeat. In the case of a one-to-one function, the y can't repeat either. Horizontal line test. If a horizontal line can be drawn so that it intersects the graph of a function at more than one point, the graph is not a one-to-one function. And remember, rise over run, also known as the slope, if 2 points are given, or difference quotient f of x plus h minus f of x over h, needless to say, the denominator, in this case h, cannot be 0. Now, let's start with the following. Find the domain of each function using interval notation. If you have a fractional format, in this case, more specifically, it's called a rational function, then you set the denominator equal to 0 and exclude it. So 2x minus 1 equal to 0, and x becomes 1/2. So a short notation would be the domain. You say x cannot be equal to 1/2. In an interval notation, from negative infinity to 1/2, union 1/2 to infinity. This is the proper interval notation for that. And this really is the meaning of that. When you have a root function, in this case, f of x equals square root of a 5x plus 4, it depends on the index. When the index is even, by the way, a missing index means 2. then what's underneath must be greater than or equal to 0. In other words, has to be, can't be negative. So 5x plus 4 is greater than or equal to 0. Can it be 0? Yes, and larger than that. And so you move the 4 and you divide by 5, and x must be larger than or equal to negative 4 over 5. How do you represent? This is an inequality. How do you represent with an interval notation from negative 4 over 5 to infinity? Because we have the equality, we use bracket, meaning the endpoints is included. However, infinity as well as negative infinity, they are concepts. You always use parentheses. F of x is x squared. The domain is all real numbers. We write r or negative to positive infinity. Why is that? Because it's a polynomial. Any polynomial function, the domain is all real numbers. This is a polynomial of degree 2. Or if you were to graph it, becomes a parabola. We continue. We are going to find the domain for this case. F of x equals cube root of x, and that would be all real numbers again. Why is that? Look at the index. The index is odd. So it's a root function with odd index. There is no restriction. F of x is x plus 3 over x squared minus 1. Remember, you have a rational function. You set the denominator equal to 0. You find what makes it 0, and you exclude that. In this case, x squared minus 1 equal to 0. Now, clearly, x squared is 1, x is plus minus 1, and therefore you are going to exclude those numbers. So this is one way to write the domain. There is nothing wrong with that. But of course, we really want to write it in an interval format. Okay, everybody? And so, having said that, the domain will go from negative infinity to negative 1, union negative 1 to 1, union 1 to infinity. The parentheses means if in all cases that that number is excluded. So negative 1 is not there, positive 1 is not there. That's the meaning of it, everybody. Okay, so it's important to understand what happens here. F of x is 2/3 x plus 7. Well, that is also a function with a domain which is all real numbers because it's a linear function. In other words, it is a polynomial of degree 1. That's pretty straightforward, everybody. Determine if the graph represents a function, a one-to-one function, and find the domain and range of each using interval notation. So, is this a function? Yes. Is this a one-to-one function? Yes. Here's the reason. You basically look at it, does this pass the vertical line test? Can you come up with any vertical line that crosses the graph more than once, or any horizontal line? This one for the vertical, this one for the horizontal line, and therefore the answer is yes in both cases. Now, what is the domain? You lay this down along the x-axis. So if I were to lay it down along the x-axis, it would cover from here to here, where this one is not covered. So therefore, it goes from 2 to 8, parentheses 2, comma 8 bracket. That's how you do that. What about the range? Then you lay this down along the y-axis and it covers from here to here. So it's from 6 to 8. And again, 6 is covered, 8 is not. This is how you find it. Is this a function? Yes, you can't come up with any vertical line that crosses more than once, but you can come up with any horizontal line easily. You look at this one. These two have the same. When they cross this horizontal line, they must have the same y coordinate. So is it a function? Yes. Is it a one-to-one function? No. Now the domain. Cut this such that you can put it along the x-axis. So it's from here to here. I hope you see that. So it covers this much. Therefore, the domain goes from here, -3 to here 2, and -3 is included, 2 is not. So that's why you use bracket here, parentheses here. Now, what about the range? If you break it down along the y-axis, it goes from here to here, which is minus from here, -5 to here, +4. So I hope you see that, how you come up with the domain and range. What about this guy? It's neither a function nor a one-to-one function, because clearly it fails a vertical line test. It fails a horizontal line test. Just draw this vertical line, for example, right here and here. Look at this horizontal line like here and here. Now, what about the domain and range? You break it along the x and along the y. So if I break it along the x-axis, this end covers this point, this end covers this point, we get from here to here. So 1, 2, 3, 4. So from -4 to 0. And then along the y-axis, we cover from here to here. So 1, 2, 3, 4. So from 0 to 4. So that's pretty obvious. I hope everybody is okay with that. It's just a matter of being able to read from the graph. All right, we are going to move on. Given the function f of x equals 2x plus 1, find and simplify f of x plus h minus f of x over h. This is important. We'll need that for the next course. So again, I want to discuss the concept first. So rate of change. If we look at the graph and we have 2 points, and we connect the 2 points, it gives us a blue line. The name is a secant line, okay? And we can calculate this. So the difference quotient, delta y over delta x, rise over run. F of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. So if we go with these two pairs just the way they are, P has coordinates x sub 1 and f of x sub 1, that is the y coordinate of P. Q has coordinates x sub 2 and f of x sub 2. So we can write it in this fashion, rise over run. And that is called the average rate of change of y, or f of x, with respect to x over the interval of x sub 1 to x sub 2, and can be interpreted as the slope of a secant line PQ. Now, there are different ways of writing it. So first, m is delta y over delta x, or f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. If we call this point A, and this point P, then this y coordinate is f of A, this y coordinate is f of a B. So we can say f of B minus f of A over B minus A. Okay. Or if this is A and we call this just X, okay, f of X minus f of A over X minus A. If this distance is H and this is A, this is A plus H. So you have f of A plus H minus f of A over A plus H minus A, which becomes H. The point is all of these refer to the same thing. The slope of the blue line, which is a secant line. And later on, we are interested in finding the slope of the red line, which is a tangent line at A comma f of A. That's what we are looking for, everybody. Okay, that's what we are looking. Now, is simply calculate this one from x plus h to x in essence. So you plug in f of x plus h, which is 2 times, so let's just write that. So f of x plus h, 2 times x plus h plus 1 minus f of x, just put this in a parenthesis, over h. And we're going to evaluate that. So let's distribute and we get 2x plus 2h plus 1 minus 2x minus 1. These two cancel each other. These two cancel each other. We get 2h over h, which is simply 2. Algebra functions. F plus minus g of x means f of x plus minus g of x. This is called the sum and the difference function. If g of x is f of x times g of x, f over g of x is f of x over g of x. Needless to say, as always, the denominator cannot be 0. In this case, g can't be 0. Given that the domain of f is A and the domain of g is B, the domain of all of them would be their intersection. What works for both of them, not just one. Needless to say, this one, of course, is a little bit more limited. Aside from that, whatever makes G 0 is excluded. So this last one, the domain for this last piece is X, which is an element of A intersection B, given that G of X is not equal to 0. So again, this is read A intersection B. Okay. This symbol is intersection. This symbol an element of, this is in set theory. This line segment is read such that. So when we want to read this, we would say the set of X as an element of A intersection B, meaning X belongs to this. That was mentioned, this set A intersection B, such that G, the denominator, can't be 0. We're talking about the last one. Okay. Let me erase my work. Composite function, f of g of x is f of g of x, g of f of x is g of f of x. And to find the domain, we write it in this fashion. And let's have a discussion as far as the domain. So x maps into g, and then what's in g mapping into f of g, and so on. So we write the domain of a composite function, f of g of x, refers to the set of all possible input values or x values for which the function is defined. The set of values from the domain of the inner function. In this case, for example, the inner function would be g of x. In this case, would be f of x. So we want to pay attention to this. The inner function, whatever that might be, g of x. So we'll talk about this one that makes g the inner function, the piece inside. F is the outer function, the shell. Refers to the set of all possible inputs x values for which the function is defined, the set of values from the domain of the inner function g of x that also produce outputs within the domain of the outer function f of x when composed. The input value must be valid for both functions involved in the composition, with the output of the inner function needing to be a valid input for the outer function. Inner function restriction, the domain of the composite function is always a subset of the domain of the inner function g of x. So this actually helps understand the concept. So what is the domain for f of g? Basically, it's the domain for g of x or smaller than that. That's the bottom line. It has to be a subset of that. Output check for a composite function f of g of x. You need to ensure that g of x, the output of the inner function, is within the allowed input of the function of f of x. So in short, whatever the domain is, and you check it further. That's the bottom line. Finding the domain. To find the domain of a composite function, first find the domain of the inner function. So in this case, f of g of x, find g of x. The domain of g of x first. In this case, g of f of x, first find the domain of f of x. Then restrict the domain further by considering which output of the inner function are valid inputs for the outer function. We will look at that, of course, with examples. That's the idea. Given the function f of x equals 2x squared plus 1, and g of x is 3x minus 5, we want to find f of g of 2. So first we are going to find g of 2. So never mind f of g of 2. So we're going to find the inner function g of 2. So that means in this case, we're going to replace 2. So we get 3 times 2, 6 minus 5 is 1. So now f of g of 2, that means f of 1, everybody. And so now we are going to put the 1 in here. And this is, of course, 1. This is 2 plus 1 becomes 3. So that's how you find composite function. F of g of x, or f of g of x, in short means into this function goes the g. So 2 times, replace the x with 3x minus 5 and square that plus 1. So reminding you, a plus minus b squared is a squared plus minus 2ab plus b squared. A squared minus b squared is a minus b times a plus b. These are some of the identities we should be very comfortable with. So having said that, this means square this. So 2 times square this, you get 9x squared. Then the product of these two, according to this, it's a minus b. A squared minus 2ab. So the product of these two and then 2 in essence. So minus 2 times 3x times 5 becomes minus 30x. Then square this one, you get 25. So distribute number 2 and we get 18x squared minus 60x plus 50. And we're going to add the 1. And here's the final answer. All right. Now we want to find GOF of x, meaning replace the x in g of x with the function f of x. That's the meaning of it. So 3 times 2x squared plus 1 minus 5. So this 6x squared plus 3. And 3 and negative 5 is negative 2. The final answer is 6x squared minus 2. Very straightforward, everybody. G of x, that means replace the x in the g function with the g itself with 3x minus 5. That's the meaning of it. So we get 9x minus 15, and these two give us minus 20. The final answer is 9x minus 20. We want to find f of negative 2. By the way, you can always find f of x and then plug in negative 2, but f of negative 2 means f of minus 2. That means find f of minus 2 first. So f of minus 2, 2 times minus 2 quantity squared plus 1. F of minus 2 means 2 times negative 2 quantity squared plus 1. And this is 4. So we get 8 plus 1 is 9. So in essence, we want f of 9. So plug in here 2 times 9 squared plus 1. 9 squared is 81. 2 times 81, 162. Plus 1, 163. Determine if the functions f and g are odd or even. So what is the definition of an even and odd function? Reminding everyone, an even function, f of minus x equals f of x, which makes it symmetric if you were to graph it WRT with respect to WRT with respect to the y-axis. Odd function f of minus x is minus f of x, which is symmetric with respect to the origin. Therefore, just look at f of minus x and observe. And when we do that, 2 times negative x quantity squared plus 1, because it's being raised to the power of 2, this remains as x squared. Therefore, this is identical to f of x, and therefore, by definition, it becomes an even function, everybody. Let's look at g of minus x. So replace the x here with negative. We get minus 3x minus 5. Now, the question is this equal to g of x? No. So it's not even. Is this equal to the opposite of that? No, because only one of them is the opposite. 3x is minus 3x, but minus 5 is the same. So it's neither nor. Therefore, g of x is neither. It's not an even function. It's not an odd function. All right. Find the average rate of change of each function on the specified interval. In this case, f of x is 3x, and we want to evaluate it from -1 to 1. Simply put, means rise over run means delta y over delta x means f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. So reminding you, rates of change are what we have already discussed. The difference quotient delta y over delta x is f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1, which is called the average rate of change of y or f of x with respect to x over the interval of x sub 1 to x sub 2, and can be interpreted as the slope of a secant line. And these are various formats. One can write them. They all really mean the same thing. Okay. So having said that, that means we want f of 1 minus f of -1 over 1 minus -1. That's what we want. That's the meaning of it, everybody. And so having said that, you plug in 1, you get 3 times 1. You plug in -1, you get minus 3 times -1. And over here, 1 minus minus 1. Obviously, this is 1 plus 1 is 2. And I hope you see that this is 3 plus 3. And therefore, we have 6 halves or 3. And we are done. So in this case, we have a different function, 2x minus 9, and we're going to go from 4 to a. So according to that, f of x sub 2 minus f of x sub 1. So we want f of a minus f of 4 over x sub 2 minus x sub 1, a minus 4. Please understand, this doesn't mean that you're dealing with a pair 4 comma a. You're dealing with, let's write that. This means you're dealing with the pair 4 comma f of 4. And this means a comma f of a. That's the meaning of this. From 4 to a. That's what it's saying. So we don't want to mix them up, everybody. Having said that, let's plug in a. So f of a is 2a minus 9. F of 4 minus, in brackets or parentheses, 2 times 4 minus 9. And the bottom is a minus 4. So this is 8 minus 9, which makes it -1. So we have 2a minus 9 minus -1, which makes it plus 1, which makes it 2a minus 8. We can factor the 2 from the numerator. And now we can drop those 2 and we get 2 and we are done. F of x is 3x plus 4 on the interval of 2 to 2 plus h. So that represents an interval. So according to this, obviously, f of 2 plus h minus f of 2 over 2 plus h minus 2. Plug in 2 plus h, and then plug in 2, meaning 3 times 2 plus h plus 4, that's inside the brackets, minus 3 times 2 plus 4, that's inside the bracket or parentheses. And the bottom is obviously 2 and minus 2 cancel each other, h. So let's distribute and simplify. So we have here 6 plus 3h plus 4. Over here we have 6 and 4, 10. With the negative is minus 10. And I hope you see minus 10 with 6 and 4 cancel each other. The numerator becomes simply 3h. Divided by h is 3, and we are done. So the difference quotient refers to the average rate of change of y with respect to x, rise over run, and there are different ways of writing it. All right, graphing techniques, transformations. Vertical and horizontal shifts. Translation, we are assuming C is a constant, is a number that is positive. By applying certain transformation to the graph of a given function, we can obtain the graph of related function, f of x plus c, and so on. So first, let me also show you the graph. So here's the graph, y equals f of x. So what happens with y equals f of x plus c? Again, we are assuming c is a positive value. It makes it easier to discuss it. So it goes up by c. That's what it says, shifted up by c units. But if you said f of x minus c, same thing shifts down by c units. Okay. F of x minus c, the same thing shifts to the right. Okay. And f of x plus c, the same thing shifts to the left. Okay. Now this one again, let me just show you the graph. Again, this is the function y equals f of x. Now, as far as the reflection is concerned, and we are assuming c is a number larger than 1. Okay. So if we multiply this by c, remember c is a number something larger than 1. So it stretches by a factor. Okay, it's a vertical direction. So it's stretched by a factor of c in the vertical direction. If it's 1 over c, okay, it shrinks. So the graph is the graph of y equals f of x shrunk by a factor of c, okay, 1 over c of x. And if we have it times f of c times x is the graph of y, equals f of x shrunk by a factor of c in a horizontal direction. This is a vertical, it's a horizontal direction. Okay. And if we happen to have minus f of x, okay, it's reflected about the x-axis. If we have f of minus x compared to f of x, it's reflected with respect to the y-axis and so forth. Some of these techniques are easier understood when we deal with trigonometry. Okay, basically in the horizontal direction, that makes more sense that way in any event. Let's look at this example. It says the following function was graphed by applying transformation to a toolkit. By that, toolkit function means essential function, means basic functions, the ones that we are supposed to know the graph. Write the equation of a function that matches the graph. So there are some basic functions that we should know the graph, everybody. These are the functions, and we're going to look at them one by one, just reminding you how they are supposed to look like. So if you hear toolkit or essential or elementary function, they all mean the same thing. One of them is a constant function, f of x equals b. That means y equals b. For example, y equals 5, y equals 2. So this one is just the horizontal line. So y equals b is a horizontal line with the y-intercept located at 0p. Then f of x equals x, the name is identity function. So basically a line that goes through the origin and it contains 0, 0, 1, 1, negative 1, negative 1. It's very easy to graph that. The next one, f of x equals x squared, it's called the square function. You know the graph is a parabola and it opens up. It's a parabola y equals x squared. So it goes through 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. So that's a graph and it opens up. One of those elementary functions, we need to know the graph. The next one is a cube function, f of x equals x cubed. By the way, when you know the graph, you know everything there is to know about it. Meaning, if we go back to here, we should recognize, of course, 0b is the y-intercept. The domain is all real numbers. The range is only one point b. This one, the domain and range is all real numbers. This one, the domain is all real numbers. The range from 0 to infinity. So the graph tells you all the information. So cube function looks like that. This is the first, this is the third quadrant. Okay, goes through 0, 0, 1, 1, negative 1, negative 1. And again, the domain is all real numbers, so is the range. Domain along the x-axis, range along the y-axis. The next one is a square root function, f of x equals square root of x. Looks like that. You should know f of x equals square root of x looks like that. So it has 0, 0, 1, 1, 4, 2, and so forth at 25, 5. You know, I'm going with easy numbers. So and again, as you look at the graph, you should recognize the domain from 0 to infinity, the range from 0 to infinity. Now, finally, f of x equals cube root of x, which is called the cube root function. It looks like that. Okay, it looks like a cube function, but it's much slower. And again, the domain and range is all real numbers, goes through 0, 0, 1, 1, and negative 1, negative 1. Just like that, but then it, becomes sluggish. So those are some essential functions. Now, to discuss that, you should recognize the absolute value function is a V shape, and it goes through 0, 0. The domain is all real numbers. The range is from 0 to infinity. And so what we call this one, this is called the vertex. So y equals absolute value of x. The vertex is located at 0, 0. So we notice this is similar to this. So somehow we have started from here to get here. So we're going to find out how we get there. So we always start with easy points. We notice this one is 0, 0, and it has moved to this new location. And so we say it's 1, 2, 3, 2 down. So this has location 3, minus 2. So the new vertex is located at 3, negative 2. So the way we would go with the absolute value is similar to the parabola, that the general form for the parabola y equals a times x minus h quantity squared plus k. In this case, we're going to go with y equals a times the absolute value of x minus h plus k, because the 0, if you plug in 0, 0, it gets this one back. Okay, with of course a, we have to figure out by putting, for example, one more point, just to give you an idea. If you put this point, and then you need one more point, for example, this one is 2, 2, can come up with the answer. So having said that, this one means this is a x minus h, the coordinate here, x minus 3, plus k plus negative 2, that means minus 2. So we are almost there. We are almost done. So all you have to do, pick any pair you want and plug in. But always go with the easy points. If you happen to have intercepts, notice clearly this is the x-intercept at 1, 0. This is the y-intercept at 0, 1. So you can choose any of it. So for example, if I choose this one, then y is replaced with 0, x is replaced with 1. 1 minus 3 is negative 2. And absolute value of negative 2 is positive 2. So this is 2a minus 2, and a becomes 1. And we replace it. And we get f of x equals absolute value of x minus 3 minus 2. Now, what I highly recommend, and I'm going to leave it for you to do so, check with, remember, we use this point, right? So check with this point check with this point, for example, and make sure it works. Okay. So for example, if you plug in 4, you get 4 minus 3 is 1. 1 absolute value is 1 minus 2 is -1. So it works. So it's a good practice to check, everybody. Always check. Okay. The following function was graphed by applying transformation to toolkit function essentials, such as one of those, as was, discussed before, right? The equation of a function that matches. And the very first thing you should recognize, again, we looked at all of those graphs, you should recognize f of x equals square root of x looks similar to that. And so this one starts with the intercept at 0, 0, which is the x as well as the y intercept. And this has shifted somewhere else. And this new location now, 1, 2, 3 to the left, 1 down. So -3, -1. And so the methodology for that is similar to what we just did. We can write, okay, so shift it to h equals -3, k equals -1. And we're going to write y equals a square root of x minus h under the radical, okay, square root of x minus h plus q. Just follow that. And so h is -3. So we write a square root of x minus -3 makes it +1 plus k, that means -1. And all you have to do, everything is there. All you have to do, plug in one more point. And what is the easiest point? You should recognize the x-intercept at -2, 0. So plug in, meaning a remains square root of, replace the x with -2 plus 3 minus 1, and replace the y with 0. And we get, let's see, this is 1. So square root of 1, okay, is 1. So a minus 1 is 0, which makes a 1, and replace it here. And that's your function. And as always, check. So if I want to check, clearly this point is 1, 1. See, the y-intercept is sort of hard to read, maybe 0.8. But go with easy ones. For sure, it's 1, 1. So if I plug in 1, 1 and 3 is 4, square root of 4 is 2, 2 minus 1 is 1. So I just checked. So check with easy points, points that you have no doubts when you read them, okay? Points that you have no doubts when you read them. I can't emphasize this enough. So having said that, let's look at this example. Again, the following function was graphed applying one of those essential functions. Write the equation of a function, and obviously this is a parabola, and everybody knows that this is the general form of a parabola with the vertex being at 0, 0, but it's no longer there, and so has a new location. So 1 to the left, 2 up, -1, 2 is the location of a vertex, everybody. So as I mentioned, y equals a times x minus h quantity squared plus k, and you are going to replace this and say a times x minus -1 makes it +1 squared, and plus k, which is 2. Okay, everything is in order. What's missing is a. All you need is one more point, and again, always go with the easy points. Obviously, this one is the easy point because you can see it's located at 0, 1. Okay, always easy point, something that you can 100% be sure as you read it. So for example, I'm not going to guess this one, okay? But for sure, this is 0, 1, although this seems to be negative 2.50, but let's not take a chance. So plug in. When we plug in 0 plus 1 is 1, 1 squared is 1. So this is 1, everybody. Simply a plus 2 is 1, which makes a negative 1. So we are going to replace it. We get the answer and we must check. So clearly this one is located at negative 2 comma 1. Negative 2 comma 1. So again, an easy point, something you can 100% read easily. So if I put negative 2 plus 1, I get negative 1. When I square it, I get positive 1. With this one becomes negative 1 plus 2 is 1. That's right. We haven't made a mistake. So I can't emphasize this enough. Make sure you do it in the same manner. Find the equation of a function that is finally graphed after the following transformations are applied to y equals x squared. So we want to shift it right. By how many units? 3 units. So x minus 3 quantity squared. Now reflect about the x-axis. Now we want to reflect this one. Okay, not that one. Now this is gone. Now we are dealing with this. Reflect about the x-axis. Put a negative sign in front. Shift it down by 2 units. So this one comes down by 2 units. So add negative 2. In other words, subtract. And that's the final answer.